All right, midpoint and distance in the coordinate plane today, section 1-6. This is an important section. We'll cover this a lot throughout the course of the year. You'll see at least one of these questions on every test that you take in here. You'll see something dealing with midpoint or distance. All right, so it's very important. If you look down here at the front of the wall, the midpoint distance formulas are down here. Okay, they will always be posted. And I'll show you some different ways to do them. You don't really even need the formulas. They're just kind of there. But midpoint distance in the coordinate plane. First thing we're going to talk about today is the coordinate plane. All right, coordinate plane is a plane that is divided into 4 regions by a horizontal axis, called the x-axis, and a vertical line, called the y-axis. Now, it splits into 4 regions. Those 4 regions are called quadrants. Now, do we know how the quadrants go?
Yes.
They go 1, 2, 3, 4. Which way? We are going
Upper right.
counterclockwise, starting in the upper right. 3, 4. That was on your Blackboard review last week, if you remember. Okay, so 1, 2, 3, 4. Those are the 4 quadrants. All right. A leg. A leg is one of the 2 sides of the right triangle that form the right angle. So imagine here I have a right triangle. The legs are what forms the right angles. Okay, so the legs form the right angles. The hypotenuse. Hypotenuse is the side opposite the right angle. So hypotenuse is the side opposite the right angle. Hypotenuse is also always the longest side. Okay, my hypotenuse is also always the longest side. All right. So if I give you a shape that was like 3, 4, and 5, which one's got to be the hypotenuse? The 5. If I give you a triangle that was 10, 8, and 6, the hypotenuse is always going to be 10. It's always my longest side. Okay, hypotenuse is always the longest side in the right triangle. And yes, those were actually right triangles I gave you. All right. Okay, we have a couple formulas we need to know here. The first one is what is called the midpoint formula. Now, if you look at it, the midpoint formula says the midpoint M of AB with endpoints x1, y1, x2, y2. Midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. It looks confusing. Think about it this way. If I gave you 2 numbers and I said find the middle of these 2 numbers, what would you do? If I give you the numbers 10 and 20, Ty, I say, hey, here's the numbers 10 and 20. Find the middle of those 2 numbers. What would you do?
Add and divide by 2.
Add and divide by 2. So how do we find the midpoint? We add and divide by 2. What do you add? Add the x's together, divide by 2. Add the y's together, divide by 2. You have your x, you have your y midpoints. Okay, so that's how you find the midpoint. Same thing here. All right, midpoint is adding and dividing by 2. Distance formula. Now this is the one students are like, oh my gosh, I can't do this. It looks tough. Okay, the formula is, yes, x2 minus x1 squared plus y2 minus y1 squared, all taken underneath the square root. I will show you an easier way to work that out. By all means, you can use the formula. Somebody earlier today was like, oh, I like the formula better. That's fine. 9 out of 10 people will probably like the other way, the shortcut way. But if you're a person that kind of sees the formula is there for you. All right? But the formula is actually derived from Pythagorean theorem. Do you guys remember Pythagorean theorem? A squared plus b squared equals c squared?
Oh, yeah.
Okay. The distance formula is actually derived from that. And you can use Pythagorean theorem there as well. So next is the example of midpoint formula. So the midpoint of a line segment separates the segment into 2 halves. You can use the midpoint formula to find the midpoint of the segment. All right. So remember, midpoint is I want to add the x's and divide by 2. So I have 1 and 7. So what's 1 plus 7? 8. 8 divided by 2 gets me 4. All right. Then I do the y's. What's 2 plus 6? 8 divided by 2 gets me, my midpoint here would be at 4, 4. That's how I find the midpoint. Add the x's, divide by 2. Add the y's, divide by 2. So let's look at number 1 here. I have the coordinates 4, 2, and -2, -1. Hannah, what are my x coordinates in the number 1 problem? Okay, there's my x coordinates. So remember, formula here is x1 plus x2 divided by 2. And y1 plus y2 divided by 2. All right? So I'm going to add my x values here. So I'm going to say 4 plus -2 divided by 2. Hannah, what's 4 plus -2? Divided by 2. So my x midpoint is 1. And then I'm going to do my y values. Aaron, which ones are my y values? 2 and negative 1. So I'm going to say 2 plus negative 1 divided by 2. What's 2 plus negative 1, Aaron? 1? Yeah? And what's 1 divided by 2 going to give me? Half, 0.5, half, either one of those. Guess what? There's my midpoint. 1.5. 1 comma 1/2. 2, I'm going to do the next one here. I want to find the midpoint. Kaylin, what are my x values here? What are my x values on number 2?
-2, 5.
So I'm going to say negative 2 plus 5 divided by 2. What's negative 2 plus 5, Kaylin? Negative 2 plus 5? 3. So I'd say 3 over 2. I could leave it as 3 over 2. What's another way I could write that? 1.5 or 1 and 1/2. All acceptable answers there. Okay, I'm going to leave it as 1.5. What are my y values here, Colton? So I have 3 plus negative 3 divided by 2. What's 3 plus negative 3, Colton? Divided by 2? So 1.5 comma 0. Nice job. 3, Alex, what are my x values? Negative 4 and? So I have negative 4 plus 6 divided by 2. Negative 4 plus 6 is what, Alex? Positive 2. Positive 2? Divided by 2 gets me 1. Seth, what are my y values? No, what are my y values? 3 and... So 3 plus negative 2 divided by 2. What's 3 plus negative 2 going to give me, anybody? 1 divided by 2 is? Half. There's my midpoint again. Do you guys remember doing this last year in Algebra 1?
Yes.
Should have done this last year. Probably should have done this a lot. All right, try these 3 on your own. Take a couple seconds, find the midpoint of these 3 on your own. All right, number 4. I want to find the midpoint. Cooper, what's the midpoint there?
Midpoint is 5 halves
5 over 2. And?
and
2. You also could have said 2.5, comma 2, or 2.5, comma 2, right? 5, Lance, what's my midpoint there?
0, negative 2.
0, negative 2, good work. And what about number 6, Cole? 3 over 2 and what? Negative 4, good work, sir. All right, so I found the midpoint of all of those. Midpoint again, add the x's divided by 2, add the y's divided by 2. Pretty straightforward. Next part here gets a little bit tougher. Okay, what happens now if they give me the midpoint and wants me to find the other endpoint? Okay, kind of. There's a couple ways to do it. Now, some of you might have learned you can do it algebraically. I'm going to show you what I call the hump method here. Okay, and you'll see it. So, think for example if let's say I had a number line. Okay, let's say I had a number line. I have A, I have B, and M's in the middle. Let's say A is at 0 and M's at 5. Okay, where's B have to be at, guys? 10. How do we figure that out? We added 5 here, right? So don't we have to add 5 here?
Yeah.
That makes sense, doesn't it? Okay, we're going to use that same philosophy now on the coordinates. We're just going to do the same thing twice, basically. Okay, so what happens here is, how do I get from my x value of 2 to my x value of 4? What am I doing? Adding 2. So what am I going to do on the other side? I'm going to... So what's 4 plus 2? Hey, look, there's my endpoint right there, 6. Now I'm going to do the y values.
Okay.
How do I get from 2 to negative 3? Minus 5. So what am I going to do again?
-5.
What's negative 3 minus 5?
-8.
Hey, guess what? There's my other endpoint now, 6, negative 8.
Wait,
Okay.
don't delete that, please.
And again, I call it the hump method because we're just showing the humps of how we're adding or subtracting. Okay? Again, some of you guys might have learned last year to do it algebraically. You have to plug it into an equation and solve. That just makes it tougher. Okay, if you just kind of think about it, that's midpoint. It makes a lot more sense. Let's try number 8. I'm going to do the same thing. I'm going to look at my x values. I'm going from 2 to 6. Lucas, how do I get from 2 to 6? I add 4. So what am I going to do after 6? I'm going to. So 6 plus 4 is? All right, great. So now I'm going to do 7 to 1. How do I get from 7 to 1? So what am I going to do again? What's 1 minus 6? Hey, guess what? There's the other endpoint, 10, negative 5. All right. Take a couple seconds to try number 9 on your own here. All right, Solomon. Number 9 here. What do you got?
4, 4.
Not 4, 4, but 4, 3. If I look at my x values, negative 6 and negative 1, I add 5. So I add 5 again, I get 4. Negative 1 to 1, I add 2. So 1 to the next one, I add 2 again, I get 3. Katie, how are we doing there? Got all this midpoint stuff down? Great. Ready to switch it up here a little bit? Let's do this thing called distance formula. All right, so the distance formula now, pay attention here. You look at this and you're like, man, there's so much going on. It's so tough already. It's really not that bad. Okay, I'll show you one way how to do it with the distance formula. Then I'll kind of show you what I call the shortcut way, which is just kind of a lot simpler to see it. All right, so distance formula. Again, what's distance formula do? It takes the difference of my x values, squares them, adds them together, and then takes the square root. And this is derived from the Pythagorean theorem. Okay, does everybody see my line over here?
Yeah.
Basically, if I were to make this into a right triangle, ooh, that's a bad one. If I were to make this into a right triangle, 4 and 6, I could use a right triangle, Pythagorean theorem. 4 squared plus 6 squared equals c squared. And I could solve it out from there. Okay. Now again, the way I'm going to show you how to do it secondly is kind of based on Pythagorean theorem, kind of a shortcut there. But I'll show you how to use the true distance formula first. So number 10 here. Distance formula states x2 minus x1 squared plus y2 minus y1 squared. Okay, so I want to identify my x values here. Ty, what are my x values?
Negative 2, 2.
Okay, there's my x values. So I'm going to say square root of 2 minus negative 2 squared plus, what are my y values, Ty?
3 and negative 2.
So negative 2 minus 3 squared. Okay, I have two negatives here next to each other. Two negatives get me a positive, right? So 2 plus 2 gets me. So I have the square root now of 4 squared plus, what's negative 2 minus 3 going to give me? Negative 5 squared. Okay. 4 squared gets me 16. Negative 5 squared gets me 16 plus 25 gets me, I have the square root of 41.
Is that the answer?
That is the answer right there. Okay, so it's kind of a long process there, and you're like, shh. That's the distance formula. That means I can plug everything in there and work the distance formula out. I'm going to show you the other way that I do it. This is how I just do it kind of quickly. What I say it is, distance formula is the difference in the x values, right? So I'm going to look at the x values here. What is the difference in those values? 4. Okay, I'm going to write that down, 4. I'm going to look at my x values, or my y values. What's the difference in my y values? So I'm going to take 4 squared plus 5 squared. What's 4 squared? 5 squared? 16 plus 25 is? Square root of 41, same answer. Is that not a lot easier? Okay. If you treat it always positively, it actually makes it a lot easier.
Yeah, you just did the same thing, but you didn't write out the first part.
Pretty much, I just made it all positive. Because that's really what it is. Yeah. So let's try number 11 now. I'll show you number 11. Okay? Gentlemen, I'm going to look at my x values. 3 to negative 3, what's my difference? 2 to negative 1, what's my difference?
3.
So I'm going to say
6 squared.
6 squared plus 3 squared. And that gets me the square root of 45. Now, Algebra 2 students in the room, how do we break down the square root of 45? Oh, so I'm not in Algebra 2 right now. You remember how to do this? How you do it? So what's the perfect square that goes into 45?
Oh, I know. 9.
9. So it breaks down as the square root of 9, the square root of 5. What's the square root of 9?
3.
So this is really just 3 square root of 5.
But can you leave it? Wait.
If you are not in Algebra 2, you can. Algebra 2 students must break it down.
Isn't that a radical?
All right, let's try number 12 here. Shh, gentlemen, quiet down here. Quiet down. Caleb, what's the difference in my x values?
That is -6.
I'm always going to treat it positively. So what is it?
6.
6. What's the difference in my y values, Caleb?
It's that's 5.
5. So I'm going to say 6 squared plus 5 squared gets me square root of 61. There's my answer. Is distance formula not that bad?
No, sir.
It's not that bad. Take a couple seconds to try these 3 on your own, using the same idea. All right, let's do number 13. Hannah, what's the difference in my x values, Hannah? What's the difference in my y values, Hannah? So I take the square root of 3 squared plus 10 squared, and you get what, Hannah? Square root of 109. Nice job. 14. Cole, what's the difference in my x values? What's the difference in my y values? 4. So I have the square root of 8 squared plus 4 squared, which is what, Cole? Shh, gentlemen. What? Isn't it the square root of 80? Okay, now Algebra 2 students, how does the square root of 80 break down?
10 and 8. 10 and 8.
16.
16 times 5.
Oh, I did.
What's the square root of 16?
Hey, I told you wrong.
4 times square root of 5.
So my answer there is 4 square root of 5. There we go. Okay, and 15, last but not least here, Layla, what's the difference in my x values?
2.
What's the difference in my y values?
6.
What?
Oh, wait.
9?
9, yeah.
I mean 6 flipped around, right? So I take the square root of 2 squared plus 9 squared, and I get the square root of what, Layla? Square root of 85. Nice job. So yeah, there's distance. Midpoint, distance, all that. Here's your assignment.